This is lesson 7.3 on similar triangles, and we will be talking about shortcut ways of figuring out whether triangles are similar. And that's very similar to when we did congruent triangles, how we started with the definition and said, by definition, you have to know all the corresponding angles are congruent, all the corresponding sides are congruent in order to make triangles congruent by definition. And then we had all the shortcuts like side angle side and side side and all those. And then we went to we're going now into similar triangles. So for similar triangles, by definition, all the corresponding angles have to be congruent and all the corresponding sides have to be proportional. So there are shortcuts, which means if you can know less information and still be able to say that the triangles are similar. So the first one is called angle-angle similarity, and that's going to say if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. These really should be stated in if-then form. Okay, and then side similarity says the measures of, if the measures of the corresponding side lengths, all the corresponding side lengths of two triangles are proportional, then the triangles are similar. And then the third one says, it's called side angle side similarity, very similar to when we did congruence. If the measures of two side lengths of one triangle are proportional to the measures of two corresponding side lengths of another triangle, then and the included angles are congruent, then the triangles are similar. So remember that sides have to be proportional, but angles need to be congruent. Okay, so just like with side angle side before, we need the angles to be included between the sides that we know are proportional. Okay, so here's applying that information. So I'm going to do this in the form I showed you before, 6 to 8 to 10. I'm putting those from short to long. Is that in the same ratio as 9 to 12 to 15? Well, on the left side, we can divide out a 2, and that will make it 3 to 4 to 5. And on the right side, we can divide out a 3, and that will make the right side 3 to 4 to 5, which means that they are proportional, so the triangles are similar by side similarity. Now for the second one, we're given a pair of congruent angles, and then we have sides that are given to be 3, 6, 4, and 8. So the angles that we need are included between the sides that are given. So that part, included angles are congruent. And then we're checking whether the sides that include those angles are proportional. So you want to check, is 3 to 6 equal to 4 to 8, which obviously those are both 1/2, which means the sides are proportional. Or you can also do the 3 to 6, is that the same as 4 to 8, which is 1 to 2, and those are the same ratio. Or you can say, if 3 over 6 equals 4 over 8, that's true if when you cross multiply you get the same thing, and that's also correct. So any of those ways will show that the triangles are similar, and they are similar by side angle side similarity because we have two pairs of sides that are proportional in the two triangles and the included angles are congruent. Now for the next problem, it's saying determine whether the triangles are similar, and so it's asking you to do a few things. So determine whether the triangles are similar. If they are, write a similarity statement and then explain how you know. Okay, so we're going to use what we know about parallel. So these two angles are congruent and these two angles are congruent. What's the reason? Well, if angle R is congruent to angle S, I should say TSL, and angle U is congruent to angle TLS, because if parallel lines are cut by transversal, then corresponding angles are congruent. Now we could have also used this reflexive angle here, but I went ahead and just used the two that use the same reason. So these triangles are similar, and it would be, the similarity statement would be triangle TRU is similar to triangle TSL by angle-angle similarity. Okay, for the second one, we've got these angles are congruent because all right angles are congruent. Angle L is congruent to angle W. And then we want to check, is the short side in the first one compared to the long side in the first one in the same ratio as the short to the long in the other one? Now again, we could cross multiply and check it, or we can divide. So for this one, let's see, how about we take out a 4 would be 5 to 9, and take out a 6 would be 3 to 4, and those are not equal. So since the sides are not proportional, I'm going to move this up a little bit here. Since the sides are not proportional, so the triangles are not similar. Now, you want to pay attention to this because a lot of people will look at that problem and think, oh, it's going to be side angle side. The triangles are similar. You've got to actually check whether the sides are proportional, because just because it looks like a side angle side does not necessarily mean that the sides really will be in the correct ratios. Okay, for this one, we've got the angles that we need given to be congruent. So angle B is congruent to angle N was given. And then we want to check their ratios. So you can stay within one triangle and compare them, or you can jump back and forth. So 24 is the short side given, and then 16 is the short side that would be compared in the other triangle. You want to know if that's equal to 39 over 26. Again, you can cross multiply or you can simplify. So divide out an 8 would make this 3 to 2. Divide out a 13 would make the other side 3 to 2. Those sides are proportional. So, similarity statement, triangle FBE is similar to triangle LNM by side angle side similarity. Okay, and then the last one looks like it's going to be side, side, side. Let's check and make sure. Shortest side here is 24. Shortest side here is 15. Medium side's 32. Medium side's 20. Long side's 40. Whoops. Long side's 40. Long side's 25. So when we compare, usually when you're doing all three sides, I prefer to do 24 to 32 to 40. Is that in the same ratio as 15 to 20 to 25? Well, let's see, take out an 8 would be 3 to 4 to 5, and take out a 5 would be 3 to 4 to 5, and those are the same, which means the sides are proportional. Now you can also compare short side, this is another option, this is OR. You could do, looking at the wrong number there, 24 to 15. What does that reduce to? Well, take out a 3, 8/5. 32 to 20. What does that reduce to? That is, take out a 4 is 8/5. And 40 to 25. Take out a 5, 8/5. since these are all the same, that makes the sides proportional. Now the good thing about doing it this way is you can easily tell that the scale factor is 8 to 5. On the previous one, for the scale factor, you have to think, okay, I divided an 8 out of this side, I divided a 5 out of this side, so the scale factor is 8 to 5. I kind of prefer to just, on that, in doing it that way, if it asks you for the scale factor, I kind of prefer to just actually pick a pair of sides and compare them and make sure that it reduces down to your scale factor. Okay, for the next example here, similar triangles. Similar triangles can be used to find measurements. Okay, so you're given triangle ABC is similar to triangle DEF this time. So we know that angle A matches with angle D, and B matches with E, and C matches with F. All right, which means that A, D, B, E, and C, F, which means it's kind of drawn correctly. We've got it in the same orientation. So across from the single marked angle is the 18, and there's the 9. Across from the double marked angle is 18 root 3 and x, and across from the triple marked angle is y and 18. Now I might want to go ahead and just say the scale factor of triangle ABC to triangle DEF is 18 to 9. Let me write that as a fraction. 18 to 9, which is the same as 2 to 1. So every side here compared to every side here is a 2 to 1 ratio. That's kind of helpful to know because we need that to set up our proportions. I just remembered that I never did kind of finish that last problem. I didn't do a similarity statement or the reason why they're similar. I'm going to go back and finish that before I forget. Triangle GHI is similar to triangle QRS by side-side-side similarity. So on that problem, those examples, we had an angle, we had ones that were not similar, we had side angle side, then we had side-side-side. Okay, back to this one. All right, so it said we're supposed to be figuring out the missing sides. I think we'll go ahead and do y first. So since the scale factor is 2 to 1, I'm just going to say y is to 18. I'm using the triangles up here. Y is to 18 as 2 is to 1, which is the scale factor. Now you can either cross multiply that and just get y equals 36 by cross multiplying, or you can kind of think, all right, 1 times 18 would convert that to a denominator of 18, which means I have to multiply the top by 18 also, and that would give us y equals 36. And then for the x value, we have 18 root 3 is to x as 2 is to 1. Pretty easy to cross multiply that, and you'll get 2x equals 18 root 3, and then we're going to divide both sides by 2, and we'll have 9 root 3. Now, there's nothing magical about the order that I set those up in. You could have, for example, said 2 is to 1 as 18 root 3 is to x. Or you could have said 18 root 3 is to 2 as x is to 1. Okay, there's lots of different ways you can set up that proportion. All of them would be fine. A person 6 feet tall casts a 1.5 foot long shadow. So in this picture, this is our 6 foot person. The shadow is 1.5 feet. And at the same time, a flagpole, which we're trying to determine the height of, casts a 7 foot long shadow. Now, the fact that it says at the same time, when the sun is in the sky, it will cast a shadow that at the same time of day in the same location would make these two angles congruent. Those are called the angles of elevation of the sun. And so these triangles are similar by angle, angle, similarity, because you already have those right triangles that are congruent. So I just want to make sure you realize why it works to set up these proportions. So for this one, our sun, again, same time of day, same location, the sun will make those two angles congruent. So the triangles are similar, which means you can say 6 has to be compared to 1.5 as x is to 7. And then I'm going to go ahead and reduce because I know that 1.5 times 4 is 6. So this is really just 4 over 1 equals x over 7. And then you can say, all right, if I'm going to multiply the bottom by 7, I have to multiply the top by 7. Or you can cross multiply and say 28 equals x, whichever way you prefer. But x would be 28, and that would be in feet. Okay, that's the end of the first half of the lesson. The next video will include the back side.